Last class we learned about polynomial long division. Today we're going to learn a shortcut called synthetic division. First thing we're going to do is see where synthetic division comes from. Now if these next two slides feel a little bit challenging to you, don't panic. What's more important is that you know how to use synthetic division. But I do want to show you where it comes from so you see that it's not some random thing. So let's go back to our example from class yesterday. And we did long division with this polynomial being divided by x minus 2. Notice that the terms that canceled out, as well as the terms that were brought down, don't really provide any unique information from where you started. So let's omit those terms. And you would have this. Next thing I'm going to do is slide this part up, and copy an x cubed. If we do that, we end up with this. So basically this simplifies the long division and just shows you all the important parts. Nothing that just canceled and nothing that was brought down. If you notice what you have, you'll see that the quotient polynomial you ended up with is the polynomial down at the bottom here. You'll also see that we had a zero remainder, and that's the number in the bottom right-hand corner. Looking at it this way is basically what synthetic division does. So here's how it works. We could have just written the coefficients from the polynomial we started with. So you had 1x cubed plus 4x squared minus 5x minus 14. The 2 out front is the 0 from this factor. So we're dividing by x minus 2. X minus 2 has a 0 at 2. That's what we write up front. And you'll notice that the 1, 6, 7, and 0 match the 1, 6, 7, and 0 down here. And here's how synthetic division works. Basically, we first bring down the 1. Or you can think of it as there's a 0 right here. We do 1 plus 0, we get 1. And what's going to happen is we're going to alternate between multiplying diagonally and adding vertically. So we add vertically straight down. Next, we multiply the 2 outside with the 1 we just had, and we get 2. And now we write that up under the 4. Next step is we add straight down the 4 and the 2, and we get 6. Now we would multiply. So we multiply diagonally the 2 and the 6 we just had, and we would get 12, and we write that under the negative 5. And then we add vertically, and we get 7. And the pattern would continue with 2 times 7, we would get 14, we would add vertically, and we'd have 0, which is our remainder. Here's an important thing to know about synthetic division. It only works when you're dividing by a linear factor or a linear divisor. Okay? And that linear divisor can only have a coefficient of 1 in front of the x. So if you had a problem where you had to divide a polynomial by a quadratic or cubic divisor, you could not use synthetic division. You would have to use long division. Another thing that's very important is just like long division, you have to account for any missing terms so that everything lines up properly. So in this example, if we have 5x cubed minus 2x squared plus 1 divided by x minus 3, we can use synthetic division because this is linear and there's just a 1 in front of the x. But like long division, we have to account for the missing x term. So the way we would set this up is we would have 5 and negative 2, and then 0 because we have no x terms, and then 1 for the constant term. And again, if we're dividing by x minus 3, the 0 of this factor is 3, and that's what we write outside. And then we go through the process where we bring down the 5, we do 3 times 5, we get 15, add negative 2 and 15, you get 13. Do 3 times 13, you get 39. Add 0 and 39, you get 39. Do 3 times 39, you get 117. Add 1 and 117, and you get a remainder of 118. That's the remainder. And then how you write the quotient is you go right to left and you start with the constant term. So this would be the constant term, this would be the x term, that would be the x squared term. So our quotient polynomial will be 5x squared plus 13x plus 39, and then a remainder of 118, and we write that remainder over our divisor. In this example, we're going to actually use synthetic division. Now, again, we can't just use it the way we normally would, because sure, this is linear, but there's a 2 in front of the x, which is an issue. There is a workaround trick. If this way is confusing to you, just use long division. But if you want to try to use synthetic division, here is the trick. You would first factor out the 2 from your divisor. So if you do that, then you're going to write inside what's left when you divide each term by 2, and you'd get x minus 3 over 2. So then what we're going to do is we're going to temporarily ignore that 2, and we're going to treat this like a normal synthetic division problem. But at the end, we have to come back and make up for the fact that we should have also divided by 2. So our synthetic division setup is we copy all the coefficients on our polynomial, and there's no missing terms, so I don't have any zeros in here. There's no missing terms in the divisor. And then since we have x minus 3 as our factor, that would have a root of 3 over 2. So we put that outside, bring down the 8, multiply 3 halves by 8, you get 12. Add negative 16 and 12, you get negative 4. 3 halves times negative 4 is negative 6. Add those up, we get 10. 3 halves times 10 is 15. Negative 27 plus 15 is negative 12. 3 halves times negative 12 is negative 18. Add those up, you get a remainder of 0. To write our quotient polynomial at the end, we'd have negative 12, 10x, negative 4x squared, 8x cubed. But we're not done, because we should have also divided by a 2 while dividing by x minus 3 halves. So all we do at the very end is we take this and we divide it by 2. So that's how the coefficients would change, which means that our final answer would be negative 6 plus 5x with a negative 2x squared and a 4x cubed out front.